Scene script. Have you ever gazed up at the night sky and wondered, how did all this come into being? From the smallest speck of dust to the largest galaxy, the universe is a vast, intricate tapestry of matter and energy. It's so expansive, so complex, that it's almost beyond human comprehension. Yet driven by insatiable curiosity, we've sought to unravel its mysteries, to understand our place within this unfathomable expanse. Our quest for understanding has led us down many paths. Some are paved with concrete facts and figures, others with theories and conjectures. We've peered through telescopes, sent probes to distant planets, and even left footprints on the moon. Each endeavor brings us one step closer to comprehending our cosmic origins. Many theories have been proposed about how the universe came into existence. The most widely accepted is the Big Bang theory, which postulates that the universe began as an infinitesimally small, infinitely hot, infinitely dense point, and has been expanding ever since. However, there are other theories too, each offering a different perspective on the birth of the cosmos. There's the oscillating universe theory, suggesting a universe that expands and contracts in an eternal cycle of big bangs and big crunches. Or the multiverse theory, which posits that our universe is just one of countless others, each with its own laws of physics. And let's not forget the string theory, a tantalizing concept suggesting that everything in the universe, from the smallest particle to the largest galaxy, is composed of tiny, vibrating strings of energy. Yet, despite our best efforts, the true nature of the universe remains elusive. We're still piecing together the puzzle, still striving to comprehend the incomprehensible. And perhaps that's the most fascinating thing about our universe. The more we learn about it, the more we realize how much we have yet to discover. The universe, as we understand it, didn't just appear out of nowhere. It has a story, a spectacular and mind-bending narrative of creation. Our journey begins nearly 14 billion years ago with a cataclysmic event known as the Big Bang. Yes, you heard it right. Think about the entire universe, every star, every galaxy, every planet, and even every atom of your body, all crammed into a space smaller than a single atom. Mind-boggling, isn't it? This was the state of the universe at the beginning of time, an extremely hot, incredibly dense point, or singularity. Then, in an instant, it began to expand. This wasn't just any expansion. It was an explosion of incomprehensible scale and power, the Big Bang. In mere fractions of a second, the universe ballooned from a singularity to an entity of colossal size. It was from this fiery, chaotic, primordial soup that everything we see around us today originated. Now you might be wondering, how do we know all this? What evidence do we have to support this mind-bending theory? Well, we have two key pieces of evidence: the cosmic microwave background, or CMB, and the redshift of distant galaxies. The CMB is the afterglow of the Big Bang, a faint whisper of radiation that permeates the entire universe. It's like the echo of that monumental explosion, still detectable after all these years. And then, we have the redshift. As we look at distant galaxies, we notice that their light is shifted towards the red end of the spectrum. This indicates that these galaxies are moving away from us, suggesting that the universe is still expanding. These pieces of evidence provide compelling support for the Big Bang theory, painting a picture of a universe that began as a tiny, dense point and has been growing ever since. It's a concept that challenges our understanding of time and space, offering a glimpse into the very origins of everything. In less than a second, the universe grew from smaller than a single atom to bigger than a galaxy, and it's been expanding ever since. So buckle up as we continue to explore this fascinating journey of cosmic evolution. From the primordial soup of particles, the first structures began to take shape: galaxies and stars. As the universe cooled, gravity began to pull matter together, forming clumps that would eventually become galaxies. Picture a colossal cosmic dance where particles swirled and twirled, drawn together by the undeniable allure of gravity. These particles didn't just randomly smash into each other. Instead, they followed the laws of physics, swirling into flat disks that spun around a central point. The center of this whirlpool of matter was so dense and hot that it ignited, giving birth to a star. Now consider a galaxy as a grand cosmic city, teeming with millions if not billions of stars. Each of these stars, like our own sun, could host a retinue of planets, asteroids, and comets. But let's focus on the stars themselves for a moment. The life of a star is a cycle of birth, life, and death. Much like any living creature on our planet, a star is born from a dense cloud of gas and dust, known as a nebula. As this cloud collapses under the force of gravity, it heats up, eventually triggering nuclear fusion. This is the moment a star is born, shining brightly as it converts hydrogen into helium. Throughout its life, a star continues to burn, creating heavier and heavier elements in its core, but nothing lasts forever. Eventually, the star exhausts its nuclear fuel. What happens next depends on the star's mass. Some stars end their lives in a gentle puff of outer layers, while others go out in a spectacular explosion known as a supernova. These celestial fireworks are more than just pretty to look at. They scatter the heavier elements made in the star's core out into the universe. These elements like carbon and iron become the building blocks for new stars, planets, and eventually, life itself. The stars are the universe's factories, churning out the building blocks of everything we see around us. So every atom in your body, the air you breathe, the ground you walk on, it all started in the heart of a star. Now isn't that something to marvel at? In the cosmic kiln of a star's death, the seeds of new worlds, including our own, were sown. This is not a metaphor, but quite literally what happens in the vast, infinite expanse of the universe. The process starts with a star nearing the end of its life cycle. As it exhausts its nuclear fuel, it begins to collapse under its own gravity. This collapse triggers a magnificent explosion known as a supernova. These violent eruptions are among the most powerful events in the universe, spreading elements like carbon, nitrogen, and oxygen, the building blocks of planets and life, across the cosmos. These elements, now journeying through space, are attracted to each other due to gravity. Over billions of years they clump together to form planetesimals, the precursors to planets. As these planetesimals continue to collide and merge, they eventually form fully fledged planets like our own Earth. But how does life fit into this cosmic ballet? Let's delve a bit deeper. Life as we know it requires certain conditions. It needs a stable star to provide light and heat, a planet with the right chemical composition, and liquid water. Earth, it seems, won the cosmic lottery. Positioned at just the right distance from the sun, with the right mix of elements and a protective atmosphere, it has all the necessary ingredients for life to flourish. And flourish it did. Starting from simple, single-celled organisms, life on Earth evolved over billions of years into the complex, diverse web of species we see today. But what about life elsewhere in the universe? Given the sheer number of stars and planets out there, it seems statistically likely that there might be other Earth-like planets. Could they too harbor life? As of now, we don't have a definitive answer. But with every new discovery, we inch closer to understanding the mysteries of life's existence in the cosmos. From the dust of dead stars, Earth was born, and in its hospitable conditions, life sprang forth. From the ashes of stellar death, new worlds and life emerge, a testament to the universe's endless cycle of destruction and creation. The universe's story is still being written, with new stars, galaxies, and possibly life forms being created even as we speak. Imagine that, a cosmic drama unfolding in real time, with each passing moment birthing new celestial wonders. Now we've come to understand that the universe is not static, it's dynamic and ever-evolving. Stars are born from vast molecular clouds in the interstellar medium, living out their lives in a fiery blaze, and then dying in a spectacular explosion. These stellar deaths seed the cosmos with the elements necessary for new stars, planets, and perhaps even life to form. It's a cycle of birth, death, and rebirth that's been going on for billions of years. And yet the universe still has many surprises up its sleeve. As we refine our telescopes and probe deeper into the cosmos, we're discovering phenomena that challenge our understanding of the universe. Mysterious dark matter binds galaxies together, while enigmatic dark energy drives the universe's accelerating expansion. These invisible forces, making up over 95% of the universe's total mass energy content, remain some of the greatest unsolved puzzles in cosmology. Looking forward, what does the future hold for our universe? Well, there are many theories. Some propose a big freeze, where the universe continues to expand until stars burn out and galaxies drift apart. Others suggest a big crunch, where gravity eventually halts the expansion and pulls everything back together. Yet another theory envisions a big rip, where dark energy tears the universe apart at its seams. While these theories may seem bleak, they're based on our current understanding of the universe. As our knowledge grows, these predictions could change. The future is, after all, as much a mystery as the past. As we continue to explore the cosmos, we're not just uncovering the universe's past, we're peering into its future. So as we gaze up at the night sky, let's remember that we're not merely observers of this cosmic ballet. We're part of the performance, contributing our own verse to the universe's ongoing symphony.